In this video, we'll be discussing the method of elimination. So up to this point, we have already seen how to solve systems both with substitution and graphing. Now we're going to consider a third way called the method of elimination. So as an example of this method, let's go ahead and solve the following system of linear equations. The idea of the method of elimination is we want to try to find a way, possibly by multiplying one of the equations or both by a constant number on both sides. We want to find a way to eliminate one of the variables by adding the two equations. So here, if we just add them straight as is, 3x plus 2y equals 4, and we add that to 5x minus 2y equals 12. Here we'll end up with 8x. Here, plus 2y and negative 2y actually cancel, and then we end up with equaling 16 on this side. But what did we just do? Well, we were able to eliminate the variable y by doing that. This now gives us that 8x equals 16, namely x is equal to 2. Now we can substitute back into either of those two equations, giving us the following. Let's go ahead and use the first equation. So 3 times 2 plus 2y equals 4. So we have 6 plus 2y equals 4. Subtract 6 to the other side, we get 2y equals negative 2. Divide both sides by 2, you get y equal negative 2. That is, we have as our solution the ordered pair 2, negative 2. And now it's time for you to try one of these simple examples. Go ahead and solve the system of linear equations given there. On the count of 3, I will reveal the solution. 1, 2, 3. So here we went ahead and we added the equations as before to get 4x equals 3. That is x equals 3/4. Then we substitute that back into the first equation to get y equals 5/2. Again, it doesn't matter when you do the substitution. It doesn't matter which equation you substitute back into, just so you know. So we get y equals 5/2. That is the point. The ordered pair 3/4, 5/2 should be our solution. Something important I didn't do the last time, but you should always do with systems, is you can check your solution by plugging in your numbers into both equations to make sure that they actually satisfy it. So that's what I did there. As far as a summary goes for using the method of elimination to solve a system of two equations, these are the following steps. First, we obtain coefficients for x or y that differ only in sign by multiplying all terms of one or both equations by suitably chosen coefficients. That sounds way more complicated than it is. You'll see when we work the next example, it's nowhere near as complicated as that makes it sound. Our second part is then add the equations to eliminate one variable. This is where we started last time because we already had the coefficients we needed. So in our first example, we were good to go, and so step 1 we didn't even need to do. So once you have added the equations to eliminate one variable, you then solve the equation that you have obtained in that one variable since you eliminated one. Then once you have that solution, you then back substitute that value obtained into either of the original equations to solve for the other variable. Then finally, as always, we must check that our solution satisfies each of the original equations. So for example, let's go ahead and solve the following system of linear equations. Here, we'd like to try to eliminate the y, so what I'm going to do is multiply. First, I'm going to multiply all of the second equation by 4. So first I have 2x minus 4y equals negative 7. And then multiplying all this by 4, I have 20x, 4 times 5 is 20, plus 4y equals 4 times negative 1 is negative 4. Add those, I get 22x. Here I did that so I can eliminate my variables there. And then I have negative 7 times plus negative 4 is negative 11. Namely, if I solve that out, I get x equals negative 1/2. Now I can go back and substitute into either of the two equations. The second equation looks a little bit simpler to solve, so I'm going to substitute in there. So I have 5 times negative 1/2 plus y equals negative 1. That is negative 5/2 plus y equals negative 1, which gives me that y is equal to negative 1 plus 5/2, which is going to be positive 3/2. Namely, my solution should be the ordered pair negative 1/2, 3/2. Of course, I should check that. I remembered this time to do so. Checking, I have 2 times negative 1/2 minus 4 times 3/2, which is negative 1 minus 6, which is negative 7, which is good. And then here, substituting into the second equation, I have 5 times negative 1/2 plus 3/2, which gives me negative 5/2 plus 3/2, which adding that together gives me negative 1. So again, I am good. And now it's time for you to try an example. Go ahead and solve the following system of linear equations. Again, pause the video if you need. On the count of 3, I will reveal the answer. 1, 2, 3. So here, I do a similar thing to what we did in the last example. I multiply the second equation by 3. As you can see there written. Doing so, I end up with 15x minus 3y equals 51. Adding up, I get 17x equals 68 and eliminate the y variable, so I end up with x equals 4. Then substituting that back into the first equation, I go ahead and I end up with 8 plus 3y. Solving out, I end up with y equals 3. So the point 4, 3 should be a solution. Plugging in, I check and make sure that in fact it is correct in both accounts. Alright, we're giving you lots of examples of doing this. If you feel like you kind of have the idea already, feel free, you can skip the rest of the video. We're just going to do more examples, so I think I have a couple more examples to work through for you, of course with U-tries as well. So let's go ahead and solve this system out. To do so, we're going to multiply. So here, I could eliminate an x or y. The book actually eliminates the y's. I'm going to go ahead and eliminate the x's instead, and so you can compare with the book then of what they did to see that it doesn't really matter. I'm going to multiply the top equation by 3, and the bottom equation by, not 3, sorry, 2. 2. And the bottom equation by negative 5. Doing so, I end up with 10x plus 6y equals 18. In the bottom, I get negative 10x plus 20y equals negative 70. Adding, those will eliminate. Here I get 26y, and here I get 18. I get 18 minus 70 is going to be negative 52. Dividing both sides by 26, I get y equals negative 2. I can substitute into either of the two equations. Let's go ahead and substitute in the second equation. So I get 2x minus 4 times negative 2 equals 14. So I have 2x plus 8 equals 14. Subtracting 8 to that side, I get 6, and so I'll have 2x equals 6, so x equals 3. So my solution is 3, negative 2. Checking the solution. Checking that solution, plugging into the first equation, I get 5 times 3 plus 3 times negative 2. which is 15 minus 6, which indeed is 9. And checking the second equation, I have 2 times 3 minus 4 times negative 2, which is 6 plus 8, which indeed is 14. And now it's once again time for you to try an example. Go ahead and try out this example. On the count of 3, I will reveal the solution. 1, 2, 3. So here I went ahead and multiplied the top equation by 2, the bottom with negative 3, because I'm trying to eliminate the x's, so I got 6x there and then negative 6x there. Eliminating, I am able to eliminate the x's. Adding, I get negative 11y there, 11 on this side, so y is negative 1. Substituting that back into the first equation, I have 3x plus negative 2 equals 7. Solving, I get x equal 3. So my point is 3 comma negative 1, and then I check my solutions. One last example, this time involving decimals. First step we're going to do is multiply everything by 100 to get rid of my decimals. I did this in one of the U-tries in the last video. So here, multiplying by 100, both of those, I end up with 2x minus 5y equals negative 38. 3x plus 4y equals 104. And now it's a little bit easier to eliminate. So we can eliminate, let's go ahead and multiply this equation by 3 and this equation by negative 2. That gives me 6x minus 15y equals 3 times negative 38. 3 times negative 38 is negative 114. Here I would get negative 6x minus 8y equals negative 208. Adding up, the x's cancel. I'm going to get a negative 23y over there and a negative 322 over here, which means y will be 14, dividing both sides by negative 23. I can substitute that back into either equation. Let's go ahead and substitute into the second equation. So I have 3x plus 4 times 14 equals 104, which is to say 3x equals 104, or 48, sorry. 48 if you do the multiplication and subtract. So x is equal to 16. So my point should be 16 comma 14. Let's check to make sure. Checking to make sure, plugging into the first equation, I get 0.02 times 16 minus 0.05 times 14. Multiplying out, I end up with a 0.32 there. Here I get 0.70, which when I do that out, I do in fact get negative 0.38. So that solves the first equation, that verifies the first equation works. Let's check that the second one works. 0.03 times 16 plus 0.04 times 14. Doing the multiplications out, I get 0.48 plus 0.56, which does in fact equal 1.04. And now, one more time, it's time for you to try an example. So go ahead and solve the following system of linear equations. On the count of 3, I will reveal the solution. 1, 2, 3. So here we go through and do the same thing and multiplying at both equations by 100 to get rid of all the decimals. Then we go ahead and we multiply by 2 and negative 3 respectively each of the equations. Eliminate the x's by doing so. End up with y equals 12, which then we substitute back into the into this equation to get x equals 9. So we have 9 comma 12 as our solution. Checking our solution, it does in fact work out. For more practice working out systems using elimination, be sure to see the textbook, pages 486 and 487. In our next video, we'll talk about a graphical interpretation of solutions, which will give us some interesting insights into what can and can't be solutions to our systems.